Hey, welcome back to the basement. I just want you to know that I shaved and put on lotion, so I did it for you. Okay, let's get to the subject. Captain Quack, it's a fucking duck on a tank. You ever seen a duck on a tank? Well, I mean, that's what it looks like, pretty much. So this is the thing I made. It is remote control. It uses a phone to control it, which is pretty neat. We've got a savage duck. You've got the top of the tank. And here you have tank treads that are actually Lego. And there's some tiny motors that I just super glued Lego gears to. So there's two motors on here. They only go in one direction. And the motors have gearing on them already. You know, these motors spin really fast, so this gear ratio is going to reduce the speed of the output and increase the torque. It's not fast, but it works pretty damn well. I was surprised at these motors. There's a little RC 3.7 volt lithium polymer battery under here. I think it's like 700 milliamp. This is all stuck together with double-sided tape, which is pretty typical of my builds. I'm using ESP81 to drive it. Why do I keep using these tiny ass microcontrollers with no inputs and outputs? I have a bunch and they're challenging, and so that's kind of nice. You could definitely just get like an ESP12E with a motor driver board under it from AliExpress or something for really cheap. That would be easier. It would actually have more features. All the motors would be able to go in both directions. I wouldn't blame you for it. I was really building this more to learn than anything, so I went the hard route on purpose. The captive portal stuff on these, very cool. You don't really have the pins to hook a whole display up to it at the same time as a sensor, so you could easily connect a phone to it over Wi-Fi to get some kind of, you know, web page interface to read that information out and maybe have some buttons and sliders and things like that. But then the problem becomes, how do you get to it? Like, you got to connect to the thing and then remember a URL, or you have to connect to it and at least tell someone, okay, once you've connected, bring up your web browser and just go to any URL, it doesn't matter, and it's going to like hijack it and jump you over to the control page. That's not so bad. But what I've been working on with this is a captive portal system that as soon as it connects, the phones will automatically think that, oh, there must be a login to this Wi-Fi network, and just bring the page up for you. And what's really cool about that is you connect to it, the page comes up, you remote control it. When you're done, you just cancel out of that. The Wi-Fi access point never gets registered as a real access point that you successfully connected to. So your phone won't automatically reconnect to it when it sees it. It's way nicer that way. The code, surprisingly huge pain in the ass. Really hard to get that to work on every platform. So we'll see how far I get. But yeah, the idea worked out really nicely. All right, let's do it.
In this case, I'm interested in using a captive portal to give my devices easy control over Wi-Fi. That way you connect with your phone and the control panel automatically presents itself. No need to remember URLs or anything. So I decided to see if I could do it with an ESP01. The ESP01 has some obvious shortcomings that complicate this, like not having much in the way of I/O, not being able to deal with much current or voltage, and just being temperamental in general. So let's talk about how to get around all these issues. I found that you could just power the ESP01s with a typical 3.7 volt LiPo cell. So I'm going to go that route again, which is nice because it'll be rechargeable. In this case, I have some tiny RC batteries that came with their own charger, so that'll be perfect. Next to the I/O issues. The ESP01 only has 4 easily usable I/O pins, and even those are not that straightforward to use. In this case, I'm just going to use the 2 basic outputs to drive 2 separate motors. We could buy some H-bridge circuits to control a couple of motors, but why make it easy on ourselves now when building a couple of simple motor drivers would be an interesting learning experience? To handle the current needs of the motors, we're definitely not going to want to send the power directly from the microcontroller. The motors would draw too much current and burn it out, so we'll use some transistors for the high current switching. Let's take a look at a common motor driver circuit. We're going to make some motor drivers using 2N3904 NPN transistors. We'll be using a resistor between them and a controller to limit the current we're pulling. The higher the current you allow to flow to the transistor base, the more current the transistor will allow through to drive the motor. We have a few concerns when considering the resistor we choose. There's a hard limit on what you could pull through the ESP8266. This is about 12 milliamps per pin. The 2N3904 transistor has a maximum current it can deal with, so we also want to make sure we don't exceed 200 milliamps. I chose a 3.3K resistor because it didn't kill the ESP01. The motors moved fast enough, and the transistors didn't get hot. Without doing the math, this seemed like a good balance. Next, we add what's called a flyback diode. This will help us deal with the back EMF from the motor. When you cut the power to the motor, there will be a collapsing magnetic field that can blast the transistor with a spike of voltage. We can protect against this by adding a diode backwards across the positive and negative connections on the motor. Normally, when the current is flowing in the intended direction, the diode won't allow it to flow across, so it will only flow into the motor. And when the current is cut off by the transistor and the motor starts blasting out back EMF in the wrong direction, it will easily flow across the diode and back into the motor, which will make use of it safely. There are strategies to picking your diode for this based on how fast you plan on switching the motor on and off, and probably breakdown current concerns. We're not using high current here or fast switching, so I'm just going with a typical 1N4148 diode. Finally, a good motor driver should probably include a few capacitors. I'll start with a 220 microfarad near the battery to help with huge current draw spikes. These can actually cause the microcontroller to reset itself. When motors first kick on, and when they experience resistance to rotation, they'll try to pull more current than normal, sometimes a lot more. Because of the speed of these spikes, batteries are too slow to cover the current draw, so we need to add a decent capacitor to cover that. Also, some motors can kick out a lot of noise back into the circuit. We can help that by adding a small capacitor across the motor connections to absorb some of that. In this case, I went with 1 nanofarad. I also added a few LEDs to make it easier for me to see the motor drivers running without having to have the motors plugged in. Once I built the circuit with these two motor drivers, I uploaded my remote control code to the ESP01 using a programmer I made in a previous video. The code is very basic once you get past all the Wi-Fi, web server, and captive portal stuff. One tricky part of this was getting the HTML and CSS data in place for the remote control webpage. This required that I use the ESP8266 FS plugin for the Arduino IDE. That's a reasonably straightforward process of just copying the plugin into the Arduino tools directory, then creating a directory next to the Arduino sketch called data, and copying all of your webpage data into that. Finally, you connect the ESP01 and run the plugin to upload it. The only big caveat here, and it's a big one, is you're going to want to make sure you're using a real FTDI breakout, not some Chinese knockoff. The uploads seemed to fail when using off-brand chips for some reason. Luckily, I had a real one laying around, because I was pulling my hair out trying to get it to work until I finally gave up and tried some other boards, and what do you know, it worked. It's not really that slow considering we have multiple gear reductions, and it can overcome simple obstacles, which I wasn't really expecting. It's a little top heavy, but it's not too bad.
So, we have the motor drivers built, we've got the motors hooked up and working, we have the ESP01 programmed and controlling it all. All the technology was proven out. Now the next step is building the top half, and that's going to be the next video. I will make the code available on GitHub, and I'll try to add comments to that. I know I didn't go into the code very much here, but that will hopefully clear things up. If it doesn't, just leave some comments, and I'm happy to go back and forth on things, and if I don't understand it, I'll find hopefully an article or something that can help both of us understand it. Now on to the next video where we build all the artsy stuff. So hope I see you there. Thanks for watching. Bye.